In the previous lesson, you learned how to relate pressure and volume. You learned that when pressure increases, volume decreases. That is an inverse relationship. In this lesson, you're going to learn about the relationship between temperature and volume and temperature and pressure. Now, for the relationship between temperature and volume, that's Charles' law. And what was discovered was that if you increase the temperature, so if you look here, if you go from 200 Kelvin to 400 Kelvin, what happens to the volume of a gas is that it actually expands, it increases. So it would go from 1 liter to 2 liters. Now, just like with Boyle's law, how we came up with a formula for that relationship, we will have one for Charles' law. But the important thing for you to remember is that when temperature increases, volume increases, so that relationship is a direct relationship. And so the formula for this one is going to be your initial volume, V1, over your initial temperature, T1. That will equal your second volume divided by your second temperature. Now, the important thing to remember for this is that your temperature has to be in Kelvin. And so what I'm going to have you do right now is just a tiny bit of practice. Remember that degrees Celsius, your temperature in Celsius, equals your temperature in Kelvin plus remember that your temperature in Kelvin equals your temperature in Celsius plus 273. So for example, if I'm going from 300 degrees Celsius and I want to find out how many Kelvin that would be, I would take 300 and add 273 to that. So your answer would be 573. Okay. I need you to complete B, C, and D for me, please, and pause the video. Now we're going to use Charles' law in order to solve this example problem. So it tells you that a balloon is inflated in a room at 24 degrees Celsius and has a volume of 4 liters. So that's the initial. It's at 24 degrees Celsius and its volume is 4 liters. Now if the balloon is heated to 58 degrees Celsius, it wants to know what the new volume is. Now, common sense tells me if I increase the temperature of the gas in the balloon, the volume would increase. But let's make sure that our answer agrees with that. Now, the important thing to remember is that I need to convert each of these temperatures to Kelvin first. So I need to add 273, so this becomes 297 Kelvin, and this becomes 331 Kelvin. All right, now we can just plug in our values and get our answer. So remember, the formula for Charles' law is V1 over T1 equals V2 over T2. Okay, so my V1 is 4.00 liters. My T1 is the 297 Kelvin, and that equals V2, I don't know what V2 is, I'm solving for it, divided by 331 Kelvin. So what I want you to do right now is to solve that. Solve for V2. The last law that we're going to look at in this lesson is Gay-Lussac's law. Now, Gay-Lussac's law relates temperature and pressure. So up until this point, we've looked at Boyle's law, which is pressure and volume. We've looked at Charles' law, which is volume and temperature. And now we're going to look at the last one, which is temperature and pressure. And then in the next lesson, we're going to take all of those laws and we're going to put them together. Now notice, just as before, if I increase my temperature from 200 Kelvin to 400 Kelvin, the pressure in the container, notice I'm not changing volume, I'm keeping volume constant, the pressure doubles as well. And so what that tells us is that when temperature increases, pressure increases as well. So that is a direct relationship. All right. Now remember, for temperature, it's got to be in units of Kelvin. Okay. And our formula for Gay-Lussac's law is P1 over T1 equals P2 over T2. So very similar to Charles' law. So let's now actually look at the first example problem, and let's do the problem together. So for number 1, it says a gas system has an initial pressure and temperature of 12 atmospheres and 27.9 degrees Celsius. If the pressure changes to 3.74 atmospheres, what will the resultant temperature be? Now, if you think about it, if I am reducing pressure going from 12 atmospheres to 3 atmospheres, my temperature should also decrease. But let's just make sure. So I'm going to use Gay-Lussac's law, P1 over T1 equals P2 over T2. Your temperatures need to be in Kelvin, so I'm going to quickly convert this one by adding 273 to it, and I get 300.9 Kelvin. And now I'm just going to plug in my values. I can use any units of pressure as long as they're the same, which they are. They're both atmospheres, so I'm good to go. So I start with 12.0 atmospheres for my pressure, and the temperature is 300.9 Kelvin. The new pressure is 3.74 atmospheres, and I'm trying to solve for the new temperature. All right, so solve for the new temperature and make sure to include the correct units.